check for invalid values, either values that are nan or values that are negative. We could do some more. Well, I think that should be good enough for now, right? And then our fill color here, and the x and y values that are going to be used in the loop. And we're going to keep this simple. We're not going to like write. I've tried to like automate all of this in one loop before, but it just ends up being more work than it should be, and then it becomes harder to read. So top and bottom lines, right? You're just going to go over the top edge x0 to x1 with the y statically at y0, and then to go over the bottom edge, you make the y1 the bottom edge, and then you do the same thing where you just increase x from the x0 to x1, and there's your top and bottom lines. For your left and right lines, exactly the same thing, but you're going to change what x and y is. So x is going to first be the left side, and then we'll move y from the top to the bottom. And then next time we're going to go over all the way to the right and move y from the top to the bottom. And there's how you get your top and bottom lines and your left and right lines. Okay, so here's our put pixel function. It's going to take the pixel container and RGBA color as separate bytes of 0 to 255, a tile x, a tile y. You could also think of tx and ty as pixel x and pixel y, whatever abstraction you want to use there. The important part is that we're thinking of these as integer coordinates. So first thing we do, we're going to extract some of the values we need to work with. We don't really use the height, but I just decided to extract all of them anyways. So the formula for index to xy in JavaScript, right, we're going to take the width and we're going to multiply it by the y, or otherwise how far down you are, to get most of the pixels that make up the index. And then after that, we're going to tack on the remaining pixels that make up the index by just taking the x value. That's basically how that formula works. Then we need the component index, so we're going to take the pixel index and multiply by the pixel components. This value should probably be 4, because there are 4 components per pixel in the code we're writing. Next thing we're going to do is set the pixel, right? And this there are 4 lines here, because the number of pixel components is 4. So there's R, G, B, and A in that order. That's the order we've been using. And we're going to stick to that. If we ever have to change the fact that RGBA is the order, we are going to have a headache on our hands, because we have hard-coded a lot of this pixel component access in our code. Okay, so the debug fill pattern pyramid, using the uniform pixels container, extracting some of the necessary values to do our calculations with right here. The pixel max value, so the width times the height, and -1, right? Because if it's the same like off by 1 error thing that applies to like if a rectangle is 64 by 64, right? It's 0 to 63 and 0 to 63 for the x and y coordinates. Same thing with the index. So the first index of when you're scanning through all of the pixels in a region is going to be 0, and therefore you have to -1 to make sure you don't go out of bounds for the pixel max index. Just a little check here to make sure there's no like nan values running around in my code. Like if this were nan or this were nan or null or undefined, right, then this calculation would throw an error. Okay, so we're going to go through every single pixel, and the reason for going through every single pixel is just because, first of all, it's simpler. It's only one loop. And second of all, you're less likely to screw up doing one loop that goes over indices, in my experience. If you absolutely do not want to miss a single pixel, doing a one-dimensional loop over every single pixel is is more likely to get that than if you do an XY loop, right? If you write your code perfectly, either way works. But if you're worried about making a mistake and you want to prioritize going over every single pixel, then you want to do it this way, right? Because now if I make a mistake, the mistake will be in the color that the pixel comes out rather than just missing the pixel altogether, if that makes sense. So your component index is the pixel index, not times the number of components, so times 4. You got tile x, tile y, so this is the index to xy formula. Let's see, pixel width. Yeah, so that's, I mean, I already know this logic is right, and I use this formula all the time, so that looks correct to me. Okay, you got your x0 and your x1, so your left bound and your right bound. So the pixel width, -1 minus tx. Right now I can't make sense of that. So you take your width, so you're all the way to the right, and then you -1, so that you're within bounds, and then you minus tx. Pretty sure that's an inversion. Why would I need to invert x, though? Like, I get why you might want to invert y, but why am I inverting x? Oh, you know what? This is x0 is x0 is distance from the left, and then x1 is your distance from the right, right? And then y0 is distance from the top, and then this is distance from the bottom. So when you're looking at the pixel, you want to know how close it is to the left, right, top, and bottom edges in order to calculate your rectangular gradient. So I could write dist from left, dist from side, right? I don't want to go over my column limit, but dist from side left, and left LEF might be a little bit cryptic, but like I use it enough in my code that that's not going to be a question to me. I always abbreviate left and right like that, not a problem. And so this is right now. The thing is with code, people might say, oh, you shouldn't write comments in your code because the code should just do what it's supposed to do, right? Besides the argument of, well, if the comment doesn't match the code, then you have a problem, and I find a lot of bugs in my code because the comment is correct, but the code is incorrect. There's another big point here. Yeah, I am smart enough to look at this and figure out what it does. But how long did it take me to figure out what that did? I did not instantly figure that out. I looked at it and was like, okay, I don't know what that does. Let me look at that. Let me think it through. Right? And then I figured out what it did. So I wasted a whole bunch of time figuring out what this did. And a good analogy there is that code is kind of like a riddle. Like, it's kind of like this puzzle you have to figure out. And then once you figure out that puzzle, you're like, oh my god, it's so obvious, right? So it took me some time to refigure out what I wrote. And then once I figured it out, I'm like, oh my god, that's so obvious, right? But it still took me a lot of time to figure that out. And don't get it stuck into that like macho egotism thing with like your intelligence. Like, just because you're smart enough to figure it out with the comment, yeah, if you have this comment, it's going to save you time, right? Because then you're like, man, I don't quite understand this right away. Oh, distance from the side left, distance from the side right. Oh, that makes sense. And then you can look at it really quick and be like, oh yeah, that makes sense. Okay, right. And then, oh, distance from side bottom, does that make sense, right? And, you know, then you got it, right? And so would you say that you have some time, if somebody gives you a riddle and then they give you the answer right away, would you say that you have somehow lack understanding because they gave you the answer? And I would say no, because the solution to a riddle is usually very simple. You just so yeah, write comments in your code. Just do it, please. So the other thing I might want to do here is that that so in here, this area right here is a rectangular gradient formula. And I'm going to make a note of that. RG, rectangular gradient formula. And we can also make a note of like how that formula works. But by choosing the so the idea is we pick whatever, we pick the shortest distance to one of the edges, right? And that's what gives us a rectangle. Color by shortest distance the shortest possible distance to any edge determines the pixel color. So another thought, so a lot of times one of the arguments against comments is, well, if they couldn't accurately express it in code, what makes you think that they're going to like be able to write it? Because, oh god, if they can't organize their thoughts in code, well, then how are they going to be competent writers? Because like writing is so much easier than writing code. So if they're good code writer, if they can write code, but they can't write it coherently, what's the probability that they can write a comment coherently? Yeah, I kind of disagree with that, because as I am writing this, I'm trying to organize my thoughts and think about it, right? And I'm actually trying to summarize what this code does, and right, you can see I struggled a little bit to get something concise, but you know, I worked on it and worked on it, and then once you get a nice concise comment about what that does, then you've helped further organize your thoughts about this code, and you've further organized your understanding of this code by writing a concise comment, right? The shortest possible distance to any edge determines the pixel color. Rectangular gradient formula. 2 sentences. So you hear me talking right now, right? I'm using too many filler words, pausing, being not all concise, right? Because this is just my train of thought, and there's no scripts. So you hear my kind of like babble. Okay, you're hearing my babble, and you hear how I talk. Okay, now compare that to this. Is this somehow inconcise? I don't think concision has anything to do with some type of innate ability. The concision of this sentence has to do with how much time and energy I put into it. It does. So saying that somebody, oh, they couldn't write coherent code, how are they going to write a coherent comment? They're going to write a coherent comment because they took the time to write a comment, and they specifically targeted coherency and conciseness, right? Anyways, moving on. So this formula, right, we're going to take the x0, x1, y0, y1. We're going to take all 4 points, which are the distances to the 4 different edges, and we're just going to filter down until we get the minimum of all of them, and that will be determining the pixel color. Now, I believe we're going to have to scale somewhere. Yeah, so right here, so only on the blue channel are we using the minimum value, and we're just going to have a value that goes from 0 to 255, depending on, so 255 would be like dead center. Well, dead center if the canvas is 512 by 512, right? Because then the center of a 512 by 512 is going to be half of that, which would be like 255, or yeah, 255, 256, somewhere around there. I'm not going to take the time to figure out my off by 1 error there. What else? How much time do we got? 15 minutes. So this is not new code. But it has been cleaned up. That's why I have a whole bunch of bookmarks around it. I just took the time to clean it up because I was happy with it and wanted to kind of clean it up so I didn't have to pay attention to it anymore. So we have a white pixel at 0, 0 and a black pixel at 1, 1, and that's because for me to detect off by 1 errors in my texture sampling, knowing where 0, 0 and 1, 1 are, it's very important because then I can quickly find something that is not registered correctly, right? If I find a black pixel at the origin when I'm running my shader code, I can be pretty sure that I have an off by 1 error. And if I don't see anything, if I don't see black or white, I can be pretty sure I have an off by 1 error somehow in the other direction. Okay, so if it's not those lower, if it's not those around the origin pixels at 0, 0 and 1, 1, then we're going to use this shader code. You'll notice that if false, right? So this never gets executed, but there's a little comment about, you know, what this statement would be used for, right? So I just want to draw lines that are 2 pixels thick. And is that correct? Oh yeah, this would draw lines that are 2 pixels thick, right? Because it isn't, this path wouldn't always get chosen. It would just be chosen more than none. Because right now this path gets chosen none of the time, and this will get this path chosen half of the time, but twice in a row. So modulus 4, right? So that's 0, 1, 2, and 3. So half of those values are going to be 0 and 1. So less than or equal to 1 is going to cover half of the values, 0 and 1, and then 2 and 3 are the other half of the values, right? So this will be true half of the time, and that's why this is going to draw lines that are 2 pixels thick. So this is for when I want that pyramid pattern to have kind of like doubly thick lines, which helps me detect problems in my sampler code that are due to some type of resolution mismatch, which it actually did help me find that error in previous recordings. And I just left it in there because I thought that was useful, and maybe if I come across this problem again, I have a solution ready to go and I can just edit the code a little bit. This might seem a little bit hacky to have some type of commented out thing with a note, but I will tell you that this is not just me. Like, this absurdity is not just me. This is, you will see kind of hacks like this in production code. Does it mean it's a good thing to do? Because, I mean, production code doesn't necessarily mean everything's done right. But what production code does mean is it's something that's living out in the wild, and production code might not be, like, theoretically or academically correct, but there's what works theoretically and academically, and then there's what actually works in the real world. So, you know, think about that. Okay, let's keep on going. So here's our uniform pixels container. And it is the container and constructor all in one. So I've been doing that for my struct types, right? I declare the struct type within the constructor just to keep things simple. Also because I'm not going to use... It's also because I'm not going to use object.create. I'm going to do it this way. And the benefit here is that I can seal the object, or if I want to freeze the object, I can also do that. I have a little bit more flexibility on what happens to that object, whereas object.create, I don't even think it's sealed. I could check, but I'm pretty sure. I'm going to make a note of that. Does object.create seal an object? Does object.create seal the object it creates? So a lot of people, when they write object-oriented JavaScript, will use object.create. I don't, because I try to stay away. I try not to use too many fancy JavaScript specific things. I want my code to be clear and easily readable, and some people will disagree with this, but I don't want you to have to be an expert at JavaScript to understand my code. I want it written simply enough that you can understand it without having to like look things up. Okay. I think the only exception is like my null checks when I use like the not symbol, but that's just because it's such a convenience that I'm like, screw it. Anyways, forget my ranting. Okay, so we got our uniform uint32 container that has not changed. Our GPU variable controller. So I'm not so fond of this. I get why it's here. It's kind of right, this object has nothing but functions in it, so really what I'm doing is I'm creating a namespace called GPU variable container. That does help me organize the code, but I don't know if that was the best way to go about it. I mean, it's here now, so we're just going to stick with it. But, you know, like, a lot of times when people are really used to, like, a object-oriented language, they will use classes just as namespaces. So it's a class, it says it's a class, but its duck type is a namespace, if that makes sense. Like, if you're familiar with, like, what duck typing means, right? Like, if it looks like a duck, walks like a duck, quacks like a duck, then it's a duck. So you can call something class and even use the class keyword, but if all it has is static methods, then its duck type is a namespace. It's just a namespace with functions, and you've decided to, like, use a class. So you've, like, over-engineered a collection of functions is what you've done. And that's what I've done here. Because now I have to create a new instance of it just to get access to these namespace functions, right? And it's a singleton too, so, right? Because we only need one of these, so nobody likes singletons, it seems. And yeah, so this thing right here is like two mortal sins as far as I'm concerned. But you know what? It's here, and I'm not going to worry about it. It works. It's here. It's not the best solution, but whatever. It's here. It is nice to have it nice and categorized where the scope, right, that indentation is basically enforced because it is in the container that it's in. I mean, I guess if you have bad indentation habits, that would not be true. But for me, since I have very good indentation habits, these indentations are enforced. So the visual categorization is kind of enforced. So it does give a little bit of organization. So I'm not totally against it, but I don't know. It's still two mortal sins, but whatever. Okay, our loop table tick function, right? And it's using some procedural style code. So you could think of the loop table as the this argument in this case. So it's not quite object-oriented. Well, whatever. Right? This would be like, if you wanted this in an object-oriented way, it would be this variable dot loop table tick. But you notice I'm mixing around a lot of OOP and procedural. Because I have reasons. Game time, loop time. Then our native window code, game objects, and the render logic. Okay, loop table tick. Okay, I'm just gonna scroll through stuff. If it's not new, I'm not gonna go over it. Okay, caps lock was screwing me up, so I made some code to ignore events that have caps lock. So what's happening is when you press a key, more than one event can be fired per cycle, and depending on, so you press the K key, and then there's like and the caps lock is pressed. An event with caps lock as the key can be fired, and then an event with K as the key can be fired. And you don't know which order those are going to be fired in. So one's going to overwrite the other because I am sharing this global event object. Eventually what I might want to do is have a queue of like 5 global event objects, and that would make it so that my code supports up to 5 key presses, 5 keys down at the same time. Not quite, right? Because it could be 4 keys down and a mouse click, or 3 keys down, a mouse click, and a mouse move, right? But the idea is if I have a queue of these objects that are being reused, then I can support multiple events being handled at the same time. And then we empty out the queue in our handler logic until the queue is empty, or flagged as empty, right? Because I'm not going to create and destroy arrays on the fly. But I'm not going to worry about that. That's a very complicated thing for later, and this keyboard handler code, event handler code, it's already complicated enough, and we really want to focus on the graphics and the rendering before we kind of hone in on the keyboard handler, because the keyboard handler is going to come way later when we're worrying about gameplay. As far as keyboard handling for the editor, we don't need super awesome responsive controls for the editor. Being able to only understand one event at a time should be fine for the editor logic. We'll just need more sophisticated logic when we're doing like gameplay logic. Okay, so this looks like a mess. Okay, so this is the fetching the editor shader code based on the editor mode, right? So different shaders for different editors. This one has not changed. It's just a default shader that kind of glows and samples the isolated memory segment. This one is the one I'm kind of working on, trying to figure out, trying to sample from the isolated memory. So we're going to take the frag chords, right, and we're going to turn those into pixel coordinates by subtracting 0.5, because the frag chord goes over all of the screen coordinates, but all of the values are they're like 0.5. If you have a texture that's 512 by 512, the frag chord will be start at 0.5 and go up to, I believe, 511.5, right? Because each coordinate is in the center of the pixel. And so we want to undo that by minusing 0.5 to get pixel coordinates in more of an integer sense, a non-OpenGL sense, because that's how I'm going to do all my logic. We're going to flip the coordinates so that the coordinates in our shader code will end up... The output results in the shader will match the graphics tradition of upper left-hand corner is the origin. If we don't flip the Y, everything is going to be topsy-turvy land. So the viewport width and viewport height, that needs to be unhard-coded. Right now, that is the correct value of the viewport. But it's not always going to be that value if I like resize the viewport dynamically while the game is running. So we can't be hard-coding these values in the shader. It needs to be stored in a uniform, but I don't want to store any more uniforms in actual uniforms. All the new uniforms I want to actually be encoded in textures. So I'm not going to fix this until I can properly encode uniforms and textures. So until I get all this math correct, I'm not even going to fix this hard coding. I'm going to stop recording.